Okay, so in this section, we're going to talk about the conjugate of the trig expression. We're going to use the conjugate to prove as one of the tools to prove identities, and then we're going to deal with odd and even identities and few other identities as well. All right. So the first thing is that just a refresher, a conjugate, and it applies to polynomials as well. If you have a binomial set up, so in this case two terms. So in this case we have the expression cos theta plus 1. The conjugate of cos theta plus 1 is cos theta minus 1. So terms are the same, it's just that the sign in the middle has changed. So and the conjugate of cos theta minus 1 is cos theta plus 1, and that applies to anything. Okay, so basically you can say the conjugate of any binomial is when you this same binomial with a change in a sign. Now let me give you an example. Let's prove this identity that we have, and in this case notice that the left hand side and the right hand side, they are both written in a very simplified form, so we can't really simplify them anymore. Look at the left hand side, the sine theta over 1 plus cos theta. So this is the part that when you multiply the top and bottom by the conjugate of 1 plus cos theta, which is 1 minus cos theta divided by 1 minus cos theta. In essence, you are not multiplying sine theta over 1 plus cos theta by anything except 1. So and because of you're multiplying by 1, you're not changing the value of that identity, and you're allowed to do that. But this will help you to get to the point, to get to the part where the left hand side will be pretty much equal to the right hand side, hopefully. Okay, so in here, let's go ahead and do the simplification. So here is, we're going to go through, so this would be sine theta times 1 minus cos theta all over 1 plus, sorry, it's a difference of a square, so I can actually go ahead and say 1 plus cos squared theta. When you multiply the 1 plus cos theta with 1 minus cos theta, that's a difference of a square, you get 1 minus cos squared theta. But what is 1 minus cos squared theta? What is that? Well, that is Pythagorean identity. So that is actually sine squared theta. So I can rewrite this as sine theta, open the bracket, 1 minus cos theta, close the bracket, divided by, and that now becomes sine squared theta. Okay? So now that we have that, we can simplify. So sine divided by sine squared. Okay, one of the sine theta, sine squared theta, one of the sine theta will go, will divide. So the final answer what we'll have is 1 minus cos theta divided by sine theta. Now, what do we have on the right hand side? On the right hand side, we did have 1 minus cos theta divided by sine theta. So now you see that after manipulating the right hand side using the conjugate, we'll end up getting the same thing. So that's where the use of a conjugate is very useful. So the next thing we're going to talk about is the concept of odd and even identities. Now you've seen this before, but we're going to review that again. So let's look at this. When we say odd and even, it's got to do with the sign of the argument of the trig. That means the angle. There's a negative in front of the angle and the way it's written like that. And in terms of the function transformation, if you remember, this negative in front of the x, not in front of the function, but in front of the x, that represents the reflection over the y-axis, the reflection of the graph over the y-axis. So now let's go through the sine and cosine and tangent to see that using Desmos. So what is sine of negative theta, and then in comparison to sine of theta. So I have got the function sine x is drawn here. Now I said x instead of theta. Just be aware that x and theta are the same. These are just an angle. Now you really see the regular graph of the sine function, and then when we put a negative in front of the x, when I engage the graph, notice that basically the graph flips over over the y-axis, and of course, so the answer to that will end up being negative. So if I go ahead and add, so let me add this equation, y equals to negative sine of x, and it gives you the exact same graph. Okay, so sine of negative x and negative sine of x will end up being the same, because it's basically reflection over the x-axis, or the y-axis is the same in this case, okay, with the other trig ratios as well. So let's look at cosine. Here it is, that's the cosine, and when we flip that over, let's see what happens. Now my prediction is that it will end up being the same. Well, it will be the same, okay? So when you have the graph that is really going forever, and you flip this over, basically this part and this part, they're exactly symmetrical, so it's just going to map. So that means this is actually equals to cos of x. How about the tangent of x and tangent of negative x? Well, it stands to reason, since tangent was the quotient identity of sine over cosine, and since sine of negative x was negative sine of x, and cosine ended up being positive, so the answer to this one will end up being negative tan of x. Okay, so let's go through. Let's just start with the tangent. We'll flip that over. Very good. And then if I stop that, here it is. So these two were the same. Excellent. So let's go back to the notes and put them in the notes. So basically the only even, so this is what we call odd and even. Odds are the ones that they have negative in front. So the sine of theta minus sine theta, tangents, okay, all of these are odd. The even values are the ones that basically are positive. So cos of negative theta will be cos of theta, and the secant, because secant was the reciprocal of cosine, that just stays positive as well. So here there are 6 of them, and you can interchange them, use them as you wish throughout the simplification of the identities or expressions of the trigs, or whatever that comes across. You can use that, including solving trigonometric equations. Okay. So here's an example. We want to simplify this. What is sine of negative pi over 6? Well, we know that's negative sine of pi over 6. And pi over 6, if you remember, that's a half, so the answer will be 1 over negative 1/2. Simple as that. That's how these come very handy, okay? And then you can continue with the cosine and tangent or whatever and apply for all of those.